How large can a star truly be? In the endless silence of the universe, this question burns like a beacon. The cosmos is filled with countless suns, each a roaring furnace of light and fusion, yet among them are titans so vast they stretch the very limits of imagination, stars so enormous that the human mind struggles to hold their scale. Imagine a sun that could swallow our own star not once but 1,000,000,000 times, a sphere of fire so colossal that the orbit of Earth would be buried deep within its heart. A furnace so wide that even Jupiter, the giant of our solar system, would vanish beneath its surface. This is not a dream born of myth or legend. It is a real star, known to astronomers as Scuti, the largest star ever measured by human eyes, a red supergiant suspended in the constellation of Scutum, glowing faintly across 9,000 light-years of interstellar dark. Its size defies comprehension. To travel around its circumference at the speed of light would take more than 7 hours. Its surface stretches across a space so immense that entire orbits, entire worlds could fit inside it. And yet, it is fragile. A dying giant, burning the last of its fuel in a final, furious blaze before its inevitable collapse. What does it mean for such a titan to exist? What secrets hide in its flickering light? And what terrifying power will be unleashed when its heart can burn no more? The stars have always been there. For as long as human eyes have gazed upward, the heavens have stretched outward in an endless canopy of light. Yet for most of history their secrets remained hidden, their distances unfathomable, their sizes beyond any measure. To early astronomers, stars were pinpoints fixed upon a celestial dome. No one could imagine their true scale, or that among them lurked giants so vast they could swallow entire solar systems whole. It was in the 19th century that the first seeds of understanding began to take root. The age of telescopes had transformed the night sky into something far richer than the ancients could ever have conceived. Instruments of glass and steel stretched human sight deeper into the universe. Through refractors and reflectors, astronomers began cataloging the stars with patience and persistence, assigning names and classifications, giving order to what had once been chaos. Observatories rose on lonely mountaintops, where the air was thin and the horizon stretched clear. The Paris Observatory, the Armagh Observatory in Ireland, the great refractors in Germany and Russia. Each dome was a silent sentinel, housing machines that extended human vision far beyond the naked eye. The stars, once mystical and untouchable, became subjects of measurement. Spectral lines revealed their chemistry. Brightness betrayed their distances. Their colors whispered of temperatures burning hotter or colder than any forge on Earth. By the early 20th century, this mapping of the sky had taken on a new precision. Photographic plates captured starlight, freezing in silver the faint glow of distant suns. These fragile plates, carried carefully into dark rooms, revealed thousands of stars too dim for human eyes alone. The cosmos was slowly being charted like a map, each point of light a data point, each coordinate a clue. It was against this backdrop of relentless cataloging that Scuti first emerged. In 1860, at the Bonn Observatory in Germany, a pair of astronomers peered through a telescope aimed at the faint constellation of Scutum. It was an unassuming patch of sky, nestled between Aquila and Sagittarius. Scutum itself was a modest constellation, known not for bright stars but for its location along the dense band of the Milky Way. And within that cluster of light, the astronomers noted a variable star, flickering gently in brightness. They recorded it in the catalog of variable stars, giving it a simple designation, Scuti. At first, there was nothing remarkable about it. Just another entry among many, marked by subtle changes in luminosity, its rhythm ticking like a heartbeat across the night sky. For decades, it remained little more than a data point, its true nature concealed behind distance and obscurity. Only with the coming of more powerful telescopes and the methods of modern astrophysics would its colossal scale be revealed. By the mid-20th century, observatories in Europe and later in Chile pushed human vision farther than ever before. The dry, high-altitude deserts of the Andes became the new frontiers of astronomy. There, beneath skies unpolluted by city lights, astronomers assembled mirrors so large they could gather light from stars thousands of times dimmer than those visible to the naked eye. In the 1970s and 80s, measurements of Scuti began to hint at something extraordinary. Its spectrum revealed it to be a red supergiant, a star near the end of its life, swollen to a size far beyond ordinary suns. But how large? That question remained elusive, for measuring the true size of a star is a challenge that stretches the limits of science. Unlike planets, stars have no solid surface. Their edges blur into the dark, their atmospheres diffuse and shifting. Measuring their diameter requires indirect methods, calculating luminosity, temperature, and distance, then combining these values with models of stellar physics. Every number carries uncertainty, yet together they build a picture of staggering scale. In the 1990s, refined measurements placed Scuti among the very largest stars ever known. Its radius was calculated at nearly 1,700 times greater than our Sun. To put such a figure into perspective, imagine the orbit of Jupiter, a vast circle more than 500 million miles from the Sun. If Scuti were placed at the center of our solar system, its fiery surface would extend beyond that orbit, engulfing Mercury, Venus, Earth, Mars, and Jupiter itself. The sheer enormity of such a star is difficult to grasp. Light, traveling at 300,000 kilometers per second, would take over 7 hours to journey from one side of Scuti to the other. Our own Sun, by comparison, is a spark beside a bonfire, a pebble next to a mountain. For the astronomers who first confirmed its size, the revelation was profound. These were not explorers armed with rockets or probes, but with glass, metal, and mathematics. Ordinary scientists peering through instruments at faint flickers of light, yet unveiling a truth that seemed almost mythological. Scuti was not just a star, it was a cosmic leviathan, a furnace of unimaginable proportions burning quietly in the distant night. Its discovery underscored the humbling nature of astronomy. For every familiar star we see with our eyes, there are countless others far stranger, far larger, and far more powerful. Scuti became a symbol of that revelation, a reminder that the universe holds wonders so vast they mock the limits of human imagination. Yet even in its enormity, Scuti is fragile. Its classification as a red supergiant means it has entered the final stages of its life. Like all massive stars, it has raced through its fuel with reckless intensity. Hydrogen is gone from its core, replaced by heavier elements in shells of fusion. Its vast outer layers are tenuous and unstable, shedding matter into the surrounding void. What we see as a giant is in truth a dying sun. The human story of its discovery is one of persistence rather than spectacle. No singular moment of revelation, but a gradual unveiling across generations of astronomers. From the faint flicker recorded in the 19th century, to the precise measurements of modern observatories, Scuti's immensity was pieced together step by step. Each observer contributed a fragment of the puzzle, and together those fragments revealed a star that defies belief. In the end, what astonishes most is not only the size of Scuti, but the fact that humanity, from its small blue world, has managed to measure it at all. Across nearly 10,000 light-years of space, through dust clouds and interstellar gas, faint photons traveled to Earth, carrying whispers of this giant's existence. Caught by mirrors captured on plates processed through mathematics, those whispers became knowledge. And that knowledge reshaped our understanding of what a star can be. The discovery phase was not the end, but a beginning. For to measure such a titan raises deeper questions. How can a star grow to such a size without tearing itself apart? What forces sustain its vast and fragile balance? And when its life finally ends, what cataclysm will erupt across the galaxy? The answers lie ahead, in the physics of dying suns, in the cycles of stellar birth and death, and in the relentless forces that sculpt the universe. But in this moment of discovery, one truth stands clear. Scuti is not merely a star among many. It is a monument to scale itself, a blazing challenge to the limits of human comprehension, and a reminder that even in the silent dark of space, there are giants waiting to be seen. When the scale of Scuti was finally revealed, astronomers were not merely impressed. They were stunned. The numbers seemed to mock the very laws of stellar physics as they were understood. Here was a star that stretched imagination to its breaking point, a bloated titan defying intuitive boundaries. For centuries, science had charted the life cycles of stars with increasing clarity. They are born in clouds of hydrogen, their cores igniting in nuclear fire. They live their lives burning fuel in predictable patterns, their paths governed by mass. Small stars burn gently, living for billions of years. Massive stars blaze furiously, exhausting their lifespans in only a few million years. And all are bound by balance. the inward pull of gravity and the outward push of fusion. That equilibrium decides how large a star can become before its own weight drags it toward collapse. But Scuti seemed to stretch that balance to absurd extremes. At nearly 1,700 times the radius of the Sun, its vast atmosphere drifted outward in layers so tenuous they seemed almost imaginary. How could such a swollen giant hold together at all? Why had gravity not already crushed it into something smaller, denser, and more stable? These were the questions that rippled through the halls of observatories and the pages of scientific journals. The comparison with our own Sun could not be more dramatic. The Sun, steady and middle-aged, has lived for 4.6 billion years and will endure for several billion more. It burns hydrogen quietly, with the patience of an ancient hearth fire. Its density is respectable, its structure stable, its energy output constant enough to nurture life on a fragile world. Scuti, by contrast, is a creature of chaos. It is young by cosmic standards, but it is already dying. Its lifespan will not stretch beyond a few million years, a fleeting spark compared to the Sun's long candle. Its mass is many times greater, and with greater mass comes greater hunger. Fuel that might have sustained a smaller star for billions of years is devoured in a few heartbeats of galactic time. Scuti lives as a roaring blaze, unstable and desperate, shedding matter as it burns. The strangeness lies not only in its size, but in its density. For all its vastness, Scuti is astonishingly thin. Its outer layers are spread across such an immense volume that the star itself is a ghostly fragile shell. A cubic centimeter of its atmosphere, a space no larger than a sugar cube, contains far less matter than the air we breathe. Some astronomers have compared it to a cosmic fog, a tenuous veil rather than a solid sphere. It is an illusion of massiveness, colossal in extent but insubstantial in substance. This paradox, and the largest star appearing almost weightless, was what shocked the scientific community. A star so swollen that its edges seemed ready to dissolve into the vacuum of space. A titan whose very immensity was also its weakness, for such stars live permanently on the brink of destruction. The physics explains part of the mystery. As a red supergiant, Scuti has exhausted the hydrogen in its core. Fusion now occurs in shells surrounding heavier and heavier elements. Each layer contributes to the star's outward pressure, forcing its atmosphere to swell. But with hydrogen gone, stability weakens. Gravity still pulls inward while the star's swollen envelope pushes outward. The result is instability, a body trembling against collapse. For astronomers, this represented both awe and fear. Awe because the scale of Scuti reveals the raw extremes of stellar evolution. Fear because such giants do not die quietly. When the balance tips, when the outward pressure falters, gravity will win in an instant. The core will implode, and the star's final breath will erupt as a supernova, scattering its elements across space. In that light, Scuti is more than an astronomical curiosity. It is a reminder of how fragile even the most powerful objects in the cosmos can be. Its immensity is not a sign of strength but of impending death. A star swollen to absurd dimensions because it is in the last stages of life. Its ghostly thin body is the visible symptom of a terminal illness. This contradiction unsettled astronomers. For if such titans can exist, then the boundaries of stellar physics are more elastic than once thought. How large can a star grow before it collapses? How thin can its structure become before it tears apart? And what happens in the violent instant when its balance finally breaks? In comparing Scuti to the Sun, the paradox deepens. The Sun, modest and stable, sustains life across billions of years. Scuti, bloated and unstable, will end its existence in destruction. Yet which star in the end leaves the greater legacy? The Sun nourishes a single planet. Scuti, when it dies, may forge heavy elements that drift into space, seeding future stars and worlds. Its violent death will scatter iron, gold, and uranium, elements born in the fury of stellar collapse. So the shock of Scuti is not merely its size. It is the lesson it teaches, that greatness in the cosmos is often inseparable from fragility. That the largest stars are also the shortest lived. That the most magnificent giants are destined to fall the fastest. Astronomers looked upon Scuti and felt both reverence and unease. It is a star that embodies paradox, standing as both a monument to scale and a warning of impermanence. Its enormity inspires awe, but its instability whispers of doom. In its flickering light lies a truth both beautiful and terrifying, that the universe creates titans not to preserve them, but to watch them collapse in fire. And so Scuti remains, suspended in the constellation of Scutum, a ghostly titan inflated beyond reason, fragile as mist yet vast enough to swallow worlds. It lives on the edge of destruction, burning furiously as its core trembles. Every photon of its light that reaches Earth is a reminder of its paradox, a star so massive yet so insubstantial that its existence defies human intuition. The scientific shock was not only the numbers written in papers or the figures calculated in observatories, it was the realization that such an object exists at all, that the universe in its silent expanses permits the birth of giants whose lives are measured in violent brevity, that size and strength in the cosmos are illusions, and that every giant carries within itself the seed of its own collapse. The shock lingers. It lingers because Scuti forces humanity to confront its own sense of scale. It lingers because it proves that the universe is capable of extremes far beyond what theory once allowed. And it lingers because when Scuti finally dies, the galaxy will not remain unchanged. The paradox of Scuti remains unsolved. It is the paradox of grandeur and fragility, of brilliance and doom, a titan of light yet already fading, a monument to power yet built on the frailest of foundations, a reminder that in the cosmos even the mightiest giants burn only for a moment, before vanishing into silence. The deeper the gaze into Scuti, the stranger the story became. Ordinary telescopes were no longer enough. To probe a star of such magnitude required instruments of greater precision, tools capable of dissecting light itself. Spectrographs became the astronomer's scalpel. By spreading starlight into its rainbow of colors, they revealed the fingerprints of elements in its atmosphere. Hydrogen, helium, carbon, oxygen, all etched their marks in the spectrum, but the lines were not steady. They shifted and wavered, betraying a star in turmoil. The gases in Scuti's vast envelope were not still. They surged outward, then fell inward again. It was as though the star itself were breathing, inhaling and exhaling in cycles measured not in seconds but in months and years. Space telescopes refined the picture further. Above the turbulence of Earth's atmosphere, the Hubble Space Telescope and its successors captured images unblurred by air. The star, faint to the human eye, revealed itself as an immense furnace glowing deep red. Its light flickered with irregularity. It did not shine with steady brilliance but pulsed, dimming and brightening, shifting like the beat of some great cosmic heart. Interferometers pushed the boundary even farther. By combining the light of multiple telescopes spread across great distances, they mimicked the power of a single colossal mirror. Through this technique, astronomers began to resolve the outlines of Scuti's swollen atmosphere. What they saw was unsettling. The star's edges were ragged and unstable, its layers drifting outward as though gravity could barely hold them in place. Vast streams of gas escaped into the interstellar dark, forming a shroud around the Titan. The numbers that emerged from these investigations staggered belief. Scuti radiates with a luminosity nearly 500,000 times that of our Sun. Every second, it releases more energy than the Sun emits in days. It blazes with such intensity that, were it not so far away, its glow would eclipse entire regions of the night sky. And yet this brilliance is not steady. It surges and falls, betraying the instability at its core. The atmosphere of Scuti is unlike anything familiar. Our Sun's surface, the photosphere, burns at nearly 6,000 degrees Celsius, a fiery ocean of plasma that radiates outward in steady waves. Scuti's outer layers, by contrast, are cooler, diffuse, and unstable. Their temperature hovers around 3,000 degrees, glowing faintly red, but stretched across such vast distances that the total energy released is immense. Its outer shell is thin enough to resemble a cosmic mist, a ghostly veil shimmering with energy. As astronomers measured the star's pulsations, they found a rhythm both mesmerizing and ominous. Scuti expands and contracts over hundreds of days, swelling outward, then retreating as though struggling to maintain equilibrium. These pulsations are not mere tremors. They are colossal upheavals driven by the star's inner convulsions. Energy surges upward from the core, pushing its layers outward, then gravity drags them back in. Each cycle releases vast amounts of material into space. The star is shedding itself piece by piece, dissolving into the void even as it continues to burn. In cosmic time, these fluctuations are fleeting. Yet from the perspective of human lives, they feel eternal. Entire generations pass on Earth while Scuti completes just a few breaths. To watch it pulse is to glimpse the heartbeat of a dying titan, a rhythm that speaks of both endurance and fragility. The deeper the observations went, the more the paradox sharpened. Here was a star millions of times brighter than the sun, yet it lived in instability. Its atmosphere, though vast, was fragile, trembling at the edge of collapse. Its brilliance was born not of strength but of desperation, as it raced through the final chapters of its life. Astronomers traced the physics driving these phenomena. The fusion in its core no longer burns simple hydrogen. Instead, shells of helium, carbon, and heavier elements ignite in succession, each layer fueling the star's outward pressure. But each step forward in fusion brings it closer to the end. With each new element ignited, the time remaining shortens. Carbon burns more quickly than helium. Oxygen more quickly still. Silicon, the last stage before iron, burns in less than a single day. Scuti has not yet reached that stage, but the clock is ticking. Its convulsions are the symptoms of a body nearing collapse. From Earth, the data builds a haunting portrait. A star so immense that its size alone stretches the imagination. A star so luminous that its light could outshine entire clusters. And yet beneath that magnificence, instability reigns. The pulsations, the fluctuations in brightness, the loss of mass into space, all are signs of mortality. The concept of a star breathing resonates deeply. On our small planet, breath is the rhythm of life, fragile and finite. To see that same rhythm in a star is to confront the kinship of all living and dying things in the universe. Scuti inhales as its layers swell outward. It exhales as gravity pulls them back. Each breath carries it closer to the end. Through instruments, models, and endless nights of data collection, astronomers attempt to decipher what lies ahead. Will the Titan collapse in a blinding supernova, scattering its elements across the Milky Way, or will it shed its layers more gently, leaving behind a core that collapses into a black hole? The evidence suggests violence. Stars of such mass rarely end quietly. The most likely fate is an explosion so brilliant it will be visible across galaxies, outshining billions of stars for a brief moment in time. Until then, Scuti persists in its strange, fragile balance. Every flicker of its light that reaches Earth tells the story of its instability. Every spectrum line recorded by a telescope whispers of gases streaming outward. Every calculation of its pulsations is a record of its cosmic heartbeat. It is a reminder that even the most powerful stars are not eternal. They are transient, fleeting in their grandeur, living in fragile equilibrium until gravity and time claim their due. Scuti may stand as the largest star ever measured, but its enormity is not permanence. It is a temporary illusion, a momentary blaze on the edge of collapse. In the deeper investigation, the truth emerges clearly. This star is not simply vast. It is unstable, fragile, and mortal. Its brilliance is the brilliance of desperation. Its light is the light of something racing toward its end, and its breath, slow and titanic, is the soundless rhythm of a giant dying in the silence of space. The more astronomers learned about Scuti, the more its presence in the galaxy became a looming reminder of what lies ahead. For all its vastness, for all its luminosity, the star is a dying giant. Its future is not measured in billions of years, but in the briefest flashes of cosmic time. Its destiny is collapse. Its end will not be gentle. Massive stars do not fade quietly into the dark. When equilibrium breaks, when the outward pressure of fusion can no longer counterbalance gravity, the result is violence on a scale that staggers the imagination. For Scuti, that end will arrive in the form of a supernova. In the final stages, the star's core will forge heavier and heavier elements, layer upon layer, until it reaches iron. Iron cannot release energy through fusion. It is the dead weight of stellar alchemy, the final limit. Once iron fills the heart of Scuti, the furnace of fusion will falter. Without outward pressure, gravity will seize control in an instant. The core will collapse inward at nearly a quarter of the speed of light. The outer layers, no longer supported, will follow, crashing down upon the imploding center. And then, in the same instant, they will rebound. The result will be a detonation so powerful that words seem inadequate. In the span of seconds, Scuti will release more energy than our sun will emit in its entire 10 billion year lifetime. Its brilliance will outshine entire galaxies. For weeks or months it will blaze across the Milky Way, visible even in daylight on distant worlds. The largest star we have ever measured will end in a flash that announces its death to the universe. The fearful scale of such an event is difficult to hold in the human mind. If Scuti were closer, if it existed not 9,000 light-years away but within just a few dozen, the consequences for Earth could be catastrophic. A supernova at such a range could strip away atmospheres, flood planets with lethal radiation, and destabilize ecosystems across entire star systems. Life as we know it would wither beneath the storm. Yet distance spares us. From 9,000 light-years, the detonation will be spectacle, not catastrophe. It will scatter its elements into the interstellar medium, enriching the galaxy with the raw materials of future worlds. Iron, carbon, oxygen, gold, all born in the crucible of a dying star. This duality haunts astronomers, for in the death of Scuti lies both destruction and creation. The violence that ends its existence will also seed the birth of new suns, new planets, and perhaps even new life. This paradox unsettles the human imagination. A single star, swollen and fragile, holds within it the power to erase or to create. Its final act will be both an ending and a beginning. To watch such a star is to confront the reality that creation in the universe is inseparable from annihilation. Stars are not eternal guardians. They are engines of transformation, cycling matter through phases of brilliance and collapse. Astronomers studying Scuti cannot avoid the deeper question it raises. If one such titan exists here, what of the countless others hidden across the galaxy? For Scuti is not unique. Other red supergiants burn in silence, waiting for the same fate. Betelgeuse and Orion, Canis Majoris, Antares. Each is a giant nearing its end, each a bomb ticking quietly in cosmic time. Some may explode within our lifetimes. Others will burn for 1,000,000 years longer. The galaxy is littered with these fragile giants, invisible threats and promises scattered among the stars. The prospect is both awe-inspiring and terrifying. Supernovae are rare in human time, yet in galactic time they are inevitable and frequent. Somewhere every few decades a massive star tears itself apart, its light racing across space to reach distant civilizations. For most of history, humanity has not been alive long enough or watching carefully enough to witness their frequency. But the universe has been bearing witness since the beginning. What unnerves astronomers most is not just the spectacle of one supernova, but the realization of scale. Multiply the fate of Scuti by the number of red supergiants scattered across the Milky Way, and the galaxy becomes a place of perpetual endings, perpetual rebirths. Every star that dies scatters the ingredients for new stars, new planets, new possibilities. Every act of destruction is also an act of creation. The cosmos itself is built on this paradox. For a moment the mind returns to Earth. Our sun, modest and steady, will never die in such violent grandeur. It will swell into a red giant, shed its outer layers and leave behind a white dwarf. Quiet, peaceful, unremarkable on the cosmic stage. Yet here in our corner of the galaxy, life has emerged from that gentler balance. And still it is possible that the atoms within us, the iron in our blood, the calcium in our bones, the gold that humanity treasures, were born in the death throes of stars like Scuti. Perhaps even Scuti itself. This realization deepens the mystery. For what is humanity, if not the dust of ancient giants? Every breath we take carries elements forged in supernovae. Every cell is constructed from matter once scattered by stellar explosions. To look upon Scuti is not just to see the future death of a star, but to glimpse our own origins. Creation and destruction are not opposites. They are phases of the same endless cycle. The mystery expands with one final question. How many of these titans remain unseen? How many supergiants burn quietly in the spiral arms of the Milky Way, waiting for their inevitable collapse? How many of their deaths will seed the next generation of worlds? Perhaps even worlds where life will rise to ask the same questions we ask now. No one can yet say. The instruments of astronomy continue to sweep the skies, cataloging, measuring, refining, but for every star we know, countless others remain hidden in the dust. Somewhere out there are titans greater still, waiting in silence. The universe does not reveal all its secrets at once. It unfolds them slowly, through light that travels for thousands of years, carrying messages from dying suns. The fate of Scuti is certain. It will collapse. It will explode. It will scatter its essence across the galaxy, whether its core forms a neutron star or collapses further into the abyss of a black hole, depends on the mass it retains in its final moments. Either path is violent, either path is final, and yet either path ensures that nothing is truly lost. The matter of Scuti will not vanish. It will become the seeds of the future. For astronomers, this is the enduring lesson. Scuti is not just a star. It is a symbol. It embodies the terrifying beauty of the universe where endings and beginnings are one. Its light carries both a warning and a promise. It warns of fragility, of mortality, of the inevitability of collapse, and it promises rebirth, transformation, the scattering of elements that will one day ignite in new stars. As the mystery deepens, one truth stands above all. Scuti is not alone. It is one among many, a single giant in a galaxy of titans, and each of them is waiting, silently, for the moment when their balance fails, when their cores implode, when their light becomes brighter than galaxies, and when they too scatter their essence into the void. The cosmos is filled with such ticking clocks. The universe is a cathedral of dying giants, and we on our small and fragile world are left to wonder not only when Scuti will meet its fate, but how many others will follow. The mystery is not whether these explosions will come. They will. The mystery is how many are out there, waiting unseen, breathing their last, their light already on its way. The presence of Scuti forces science into uneasy speculation. For in its enormity lies a challenge. How can a star grow so vast without tearing itself apart? Stellar evolution models built from decades of observation and theory describe the paths of stars from birth to death. Yet Scuti sits at the outermost edge of those models, testing their boundaries, stretching the very equations of physics. Stars are governed by a simple yet profound struggle. Gravity pulls inward, trying to compress their mass into collapse. Fusion pushes outward, a relentless explosion in the core that resists gravity's grip. In small stars, this balance is stable, lasting billions of years. In giants, the equilibrium is fragile, a delicate act poised on the edge of catastrophe. In Scuti, nuclear fusion rages at unimaginable scales. Deep within its core, hydrogen has long since been consumed, replaced by the burning of helium, carbon, and heavier elements in layers stacked like the rings of a tree. Each stage releases energy, but each burns faster than the last. What takes hydrogen billions of years is accomplished by helium in only millions. Carbon burns in thousands, oxygen in mere months. Silicon, the final stage, burns in less than a single day before the inevitable collapse. The scale of fusion in such a star is nearly incomprehensible. Reactions that convert matter into energy at a rate that powers brilliance visible across thousands of light years. Some theorists suggest that stars like Scuti may not end merely in supernovae, but in hypernovae. These are explosions even more powerful than their already cataclysmic cousins. Events that unleash not only light and shock waves, but jets of energy piercing across the galaxy. Such explosions may give rise to gamma-ray bursts, narrow beams of radiation so intense that, if directed toward Earth from even thousands of light years away, they could sterilize the planet in seconds. The thought unsettles, for it means that stars like Scuti are not only giants but potential monsters, holding within them destruction on scales that defy imagination. And yet, they may also be the universe's most generous creators, for in the violence of their deaths, they forge the heaviest elements. Lighter stars create carbon and oxygen, but it takes titans to generate gold, uranium, and the heavy metals that shape planets and power chemistry. Without the deaths of such stars, there would be no iron in the blood of animals, no calcium in the bones of living creatures, no rare elements embedded in the crust of worlds. Life itself is a legacy of supernovae. This duality lies at the heart of the mystery. Is Scuti a monster bloated and unstable, destined to release chaos into the galaxy? Or is it a cosmic parent, carrying within its collapse the ingredients of worlds yet unborn? Perhaps it is both, a destroyer and a creator, a reminder that the universe does not divide neatly into good and evil, but weaves both into the same fabric. Philosophers of science reflect on this paradox. The enormity of Scuti humbles not only physics but meaning itself. A star so large, so luminous, exists only briefly, then collapses. It is a monument to impermanence, proof that even the greatest cannot endure. And yet its death ensures continuity. It does not vanish without leaving a trace. It reshapes the galaxy in its final act, scattering seeds for generations yet to come. Theorists construct models to predict its exact fate. Will it collapse into a neutron star, A dense remnant packed so tightly that a teaspoon of its matter would weigh billions of tons? Or will its mass exceed even that threshold, pulling its core into the abyss of a black hole? If so, Scuti's death could ignite one of the most energetic events in the cosmos, a gamma-ray burst blazing like a cosmic lighthouse across millions of light-years. These events are rare but devastating. Some astronomers suggest that past gamma-ray bursts may have altered the course of life on Earth, stripping atmospheres and extinguishing species in moments. The possibility ties the fate of such stars directly to the history of life. And if this is true, then stars like Scuti shape not only galaxies, but the very trajectory of biology. They dictate which planets retain their atmospheres, which ecosystems survive, and which species rise. Their explosions may both erase and enable life, pruning the universe while also seeding it. To think of Scuti as only a monster is too simple. Its immense body is fragile, trembling on the verge of collapse. Its death will be catastrophic, yes, but it will also be fertile. Within its light lies the paradox of the cosmos: creation through destruction, permanence through impermanence. Some speculate that such stars may even be the architects of cosmic diversity. Without their deaths, the universe would remain a barren expanse of hydrogen and helium. With them, it becomes a place of complexity, chemistry, and life. Every galaxy carries the fingerprints of its dead giants. Every planet is built from their remnants. Every living being carries their dust. In this light, Scuti is not only an astronomical curiosity, it is a symbol of our origins. It is a reminder that humanity owes its existence to the deaths of ancient stars, that every heartbeat, every breath, every thought is made possible by explosions more violent than anything the Earth has ever known. Still, the monster remains. Hypernovae and gamma-ray bursts cannot be ignored. They remind us that creation is not gentle. The universe is not shaped by kindness but by violence that is also generosity. The same titans that give rise to gold and oxygen can unleash beams of radiation that sterilize entire worlds. This tension gives Scuti its power over the imagination. It is at once terrifying and nurturing, monstrous and parental. And perhaps that is the greater truth. The universe is not concerned with labels nor with human categories of fear or comfort. It creates titans like Scuti not to frighten or to comfort, but because physics allows them to exist. They rise, they burn, they collapse, and in their wake, the universe is changed. As astronomers refine their models and watch the flickering light of Scuti, they do so with both reverence and unease. Reverence because they are witnessing a star at the outermost edge of what is possible. Unease because they know its death will be violent beyond comprehension. Theories multiply, simulations run, but the star itself continues its slow, fragile breathing in the dark. What Scuti reminds us is that speculation is not weakness, but necessity. For in confronting such extremes, science must extend beyond certainty. It must imagine, theorize, and dream. In the end, the models of stellar evolution are not just equations. They are attempts to place meaning on the blazing, dying heart of a titan. And so Scuti waits, a fragile giant, destined for collapse, destined for transformation, a star that will one day detonate, releasing violence and beauty in equal measure. Whether it is a monster or a parent is not the universe's question. It is ours. In its light we see both terror and belonging. In its death we will see both destruction and renewal. And in its existence we are reminded that the cosmos itself is born of paradox. Scuti is both, monster and parent, titan and ghost, destroyer and creator, a blazing symbol of the mystery at the heart of the universe itself. The light of Scuti has traveled for nearly 10,000 years to reach Earth. Every photon that touches a telescope tonight left the star before human civilization had learned to write. Before pyramids rose from desert sands, before history itself began. To study such a titan is to look back in time, to catch echoes of a past that still shapes the present. Yet distance is only one of the obstacles. The true challenge lies in piercing its mystery with tools fragile, compared to the enormity of what they attempt to measure. Humanity has built those tools with patience and ingenuity. On mountaintops, deserts, and in orbit above the Earth, instruments stand as sentinels, straining to capture the faintest whispers of Scuti's radiance. Each one extends the reach of human senses, converting invisible photons into data, transforming starlight into knowledge. The Hubble Space Telescope, suspended in the stillness of low Earth orbit, was among the first to bring clarity. Free of the turbulence of atmosphere, It gazed across interstellar dust and revealed the faint glow of red supergiants. In its images, Scuti appeared not as a single steady flame, but as a trembling light, shifting in rhythm, betraying instability. From the ground, the very large telescope in Chile's Atacama Desert added detail. Its array of 4 massive mirrors worked in concert, gathering light from across the heavens with extraordinary precision. Through its adaptive optics, the atmosphere's blurring was undone, and the surface of Scuti began to emerge not as a perfect sphere, but as a chaotic and ragged frontier. Interferometry took the next step. By linking telescopes together, light collected at separate points was combined into a single, sharpened image. This technique allowed astronomers to resolve features far beyond the limits of any single instrument. Scuti's surface became a map of turbulence. Vast convective cells rose and fell like continents of fire, each larger than entire planetary orbits. Its outer layers streamed into space, forming plumes that extended millions of kilometers into the void. The star did not appear calm but alive, restless, unstable. Yet even these instruments are only the beginning. The James Webb Space Telescope, launched in the early 21st century, shifted humanity's gaze deeper still. With mirrors coated in gold and instruments cooled to near absolute zero, Webb opened new wavelengths of the infrared sky. It pierced dust clouds that obscure visible light and revealed the faint glowing winds of supergiants as they shed their atmospheres. For Scuti, Webb's data traced the flow of matter streaming into space, the star's own body dissolving into the interstellar medium, a slow unraveling of its colossal form. Still, telescopes cannot do everything. Light alone does not answer the question of when the giant will collapse. To approach that mystery, scientists turn to supercomputers. Inside vast machines, equations of stellar physics are written into code. Models are run, billions of variables calculated in parallel, as virtual stars are born, evolve, and die. These simulations attempt to capture the violence of collapse, the convulsions of fusion, the moment when equilibrium shatters and the core implodes. In those simulated deaths, astronomers see reflections of Scuti's fate. Some models predict supernova, others suggest hypernova. Some envision black holes forming instantly, others neutron stars glowing faintly in the dark. Each possibility carries its own echoes for the galaxy, yet none can predict the exact timing. The physics is complex, sensitive to small variations in mass, temperature, and rotation. The star may collapse tomorrow or in 100,000 years. To cosmic time, both are equally soon. The challenge of prediction underscores the difficulty of distance. From nearly 10,000 light-years away, even the most advanced instruments capture only a fraction of the story. The starlight that arrives now is already ancient. If Scuti had collapsed in the last 9 millennia, we would not yet know. Perhaps even now, as astronomers watch its trembling light, the star has already exploded, its shockwave racing outward, its final message still crossing the gulf of space. The instruments can measure, simulate, predict, but they cannot overcome the delay of distance. And yet humanity persists. Not out of fear, but out of wonder. To study Scuti is not merely to safeguard against cosmic catastrophe, but to understand the limits of what the universe can build. The instruments and simulations are monuments to curiosity, proof that across centuries and civilizations, human beings have sought not only to survive beneath the stars but to comprehend them. Every new telescope expands the canvas. The square-kilometer array, under construction across Africa and Australia, will listen to the faintest radio whispers of dying giants. Next-generation interferometers will sharpen the details of stellar surfaces even further. Supercomputers will grow, their models more complex, their predictions more precise. Each advance brings Scuti into clearer focus. Yet each raises new questions, new mysteries, new reasons to look again. The relentless pursuit of such knowledge reveals something profound about the human condition. Against the scale of Scuti, humanity is insignificant, a flicker on a pale blue world circling an ordinary star. And yet, fragile though it is, humanity builds instruments that reach across thousands of light years. Minds born of stardust calculate the collapse of giants. Hands that cannot touch the sky still shape mirrors that catch its light. The tools of science are not weapons against fear, but bridges to wonder. They allow humanity to ask questions once reserved for myth. What is the fate of a star so large it defies comprehension? How does it breathe, convulse, and collapse? When will it scatter its essence into the galaxy? These questions are not born of dread but of awe. To answer them is to better understand the fabric of the cosmos and the fragile place of humanity within it. And so the testing continues. Night after night, telescopes watch. Year after year, simulations run. Each new piece of data is a fragment of the story. Each observation brings Scuti closer, even as it remains impossibly far. And through this pursuit, one truth shines clearly. The quest is not for certainty but for connection. To see a star like Scuti is to witness the universe writing itself. To study it is to read that writing aloud. In the end, the instruments, the models, the predictions are not only about a dying star. They are reflections of humanity itself, fragile creatures looking into the night, driven not by fear of what they may find, but by the wonder of knowing they can look at all. In the constellation of Scutum, 9,000 light-years away, a star waits in silence, Scuti, immense, unstable, flickering at the edge of collapse. It does not rage with noise, for the cosmos has no sound. It burns in silence, its heartbeat measured only in pulses of light. It is there now, immense and patient, a titan suspended in the dark. To look upon such a star is to feel both wonder and unease, for in its glow lies a reminder of fragility. Our sun, modest and steady, has burned with constancy for billions of years. Its rhythm is gentle, its stability the foundation upon which life has flourished. Yet beyond our system, the galaxy burns with chaos. Supergiants like Scuti tremble, swell, and collapse, their brilliance as fleeting as it is vast. They are beacons of impermanence, glowing with a light that foreshadows destruction. It is here that philosophy touches science. Humanity, fragile and temporary, stands in the light of stars that create and destroy worlds. Every atom of every person has passed through furnaces like this. The calcium in bones, the iron in blood, the oxygen in lungs, all forged in the deaths of giants. The very possibility of thought, of breath, of life itself is written in the ashes of collapsed stars. To study Scuti is to study origins as much as destiny, and yet its enormity carries a darker reflection. If such terrifying power exists in one corner of our galaxy, how many more titans remain unseen? How many giants swell and flicker in the spiral arms of the Milky Way, each waiting for the moment of collapse? How many explosions have already ignited, their light still racing toward us across gulfs of space and time? The night sky, serene to human eyes, is a battlefield of giants, each one shaping the destiny of the galaxy in its death. In this truth lies humility. For humanity can measure, calculate, and name such stars, yet they remain beyond us, beyond control, beyond comprehension. We give them catalog numbers, record their pulsations, trace their light across centuries, but their existence is older than our civilizations, their futures longer than our species. They do not burn for us, yet their light defines us. They are reminders of both our insignificance and our endless curiosity. Scuti endures as a paradox. It is vast yet fragile, brilliant yet doomed, monstrous yet generous. Its death will be violent, yet it will scatter the ingredients of life into the galaxy. To gaze upon it is to feel terror and belonging at once. Terror, for its power is unimaginable. Belonging, for we are made of the same matter, children of the same cycle. In the end, this is what such titans teach, that the universe is not only a place of order and stability, but of chaos, destruction, and rebirth, that every act of creation is bound to an act of annihilation, that fragility and enormity are not opposites but partners in the story of the cosmos. Scuti, waiting in silence, is both a warning and a gift. A warning of impermanence, of the inevitability of collapse, a gift of perspective, reminding humanity of its place in a universe filled with giants. Perhaps one day, its light will flare brighter than galaxies, a final message blazing across the Milky Way. Perhaps, long after humanity is gone, it will scatter the dust that becomes new worlds, new suns and new lives. For now it waits, silent, trembling. Vast beyond imagination, we measure it, we name it. But in truth it remains beyond us. A cosmic giant whose terrifying power reminds us of both our insignificance and our endless curiosity.